Hi guys, we're gonna talk about angle of elevation, angle of depression. We're gonna see if this works okay. I don't know how it's gonna play out. So you want to be able to use trig to solve word problems, real world problems. So you want to talk about an angle of depression and an angle of elevation. And an angle of depression is formed by a horizontal line like this one right here and the line of sight looking down to an object. So, like, assume you're in the hot air balloon up here and you look down at your friend on the ground. That would be an angle of depression. Okay. And the line of sight is this line right here. Line of sight is the line when you look up or look down to something. And the angle of elevation is when your friend is down on the ground and he or she looks up at you in the hot air balloon. And notice that your horizontal lines are parallel. So remember that alternate interior angles are congruent. So that's why those angles are the same measure. Okay, so the main thing, the important thing to remember about angle of elevation and angle of depression, really the one of the most important parts, is always has to be formed by a horizontal line. So it has to be formed with a horizontal. It can never be formed with a vertical. And then with a line of sight looking up to something or looking down to something. So looking down if it's towards an object, if it's an angle of depression, and looking up towards an object if it's an angle of elevation. Okay, so we're going to describe each angle as it relates to the situation, assuming that you are at the top of this mountain, or somebody's over there and looks down at this hiker over here. Then angle one would be called a, what do you think it's called? I know I can't hear you, but what do you think it's called? Think about it for a second. That's an angle of depression. Yikes. If I could spell depression, that'd be great. And if the hiker looks up at you at the top of the, standing at the top of the mountain, remember here's the horizontal line if he's looking straight ahead, and then he looks up at you, and that's an angle of elevation. And then if the hiker looks down at, I don't know, let's say his dad is down there at the cabin across the river, and he looks down, this is the line of sight, and he looks down towards somebody sitting over here, then that's an angle. Angle 3 is an angle of depression. I don't know why I keep putting a G first. And if his dad is at the cabin sitting there and he looks straight ahead, he'd be looking at the ground or across the river. But then if he looks up towards that hiker, that's an angle of elevation. Notice that each of those is formed with a horizontal. Moving on. Okay, so this example is pretty challenging. Um, you want to find the height of Delicate Arch in Arches National Park in Utah. So a surveyor levels a theodolite. That's a measuring device. If you don't know what that is, you can Google what a theodolite is. With the bottom of the arch, and from there she measures the angle of elevation to the top of the arch. She then measures the distance from where she stands to a point directly under the arch, and her results are shown in the diagram. So here's the Delicate Arch right here, and then the surveyor is over here. This tripod-looking thing is the theodolite, okay? And the surveyor is at a distance away from the arch. It looks like 36 feet right here, 36 feet away from the arch, okay? And it's hard to tell that this is a right triangle, so you have to just kind of imagine that you're at an angle here and you're seeing some piece. So this 5 feet right here, this represents how high above the ground that theodolite is. So you got to be careful to make sure you add that back in after the fact. So if you want to find the height from the bottom of the ground, like right there, all the way to the top, right? So imagine that from here in the picture where that guy is standing to the top of the arch, this is what you're trying to measure a little bit. That would actually be like x plus 5, okay? So think about taking that triangle and turning it on its side a little bit. And if you turn it on its side, and here's the 5 feet, and here's the 48-degree angle, and the theodolite is 36 feet from the spot directly underneath the arch. And x is like remember that you're measuring the theodolite from where the theodolite makes a horizontal line up to the top of the arch. This would be that line of sight that we're talking about, right there. And there's your horizontal. Don't forget that it's got to be made with a horizontal. So which trig function? Remember, you got to ask yourself, where are the sides in relation to the angle? So here's an x, and here's a 36, and this is opposite. And 36 is adjacent to the 48. So which trig function is opposite and adjacent? That's tangent. So tangent of 48 degrees is equal to x over 36. And then remember that you have to multiply both sides by 36. And you get 36 tangent of 48 equals x. Don't forget that what are you going to have to do at the end to find the total height? Add the 5 feet in at the end. And that should do it. Okay, so the final answer that I got was approximately 45 feet. And even if I do that to the nearest tenth, it would still be 45.0 feet. Don't forget that after you type in 36 tangent of 48, you have to add 5 feet in at the end of the problem. Okay, I'm going to try to go through these others pretty fast so that you don't get super bored. You can print, don't forget that you can print the notes blank, and you could kind of fill them in and try to do some stuff on your own, and then just check your answers if that's easier for you rather than watching the whole entire video. Okay, so an airplane is flying at an altitude of 3,500 feet, begins a 2-degree descent to land at JFK. How many miles from the airport is the airplane when it begins its descent? Be careful, because how many miles from the airport is the airplane when it begins its descent? That's a little bit of a tricky question. It's like, do you want the horizontal distance or the direct distance? I'm going to tell you right now, I want the direct distance that the plane has to fly. And if you think that I'm not being clear about that, then you can certainly ask. So I'm going to sketch in a plane here. Please forgive me from a plane being bad. It just is what it is. And if the plane were going straight, the horizontal line would be like this. And then we want a 2-degree descent. So if you've never ridden in a plane, just think about that. You've maybe seen movies. Here's JFK Airport. And here's your 2-degree angle of descent that he's going to go down. And the flying at an altitude of 3,500 feet, that's important. That's just how high above the ground the airplane is. So this is your 3,500 feet right here. Obviously, he's pretty low right now coming in for a landing. And every single time that you do one of these application problems, you should end up with a right triangle, because that's really what we're doing. And then what I'm going to do is I'm going to use alternate interior angles to put the 2-degree angle over here. And now we're going to use trig to figure out, and remember that I asked you for the direct distance. So this is really what I want to know, is I want to know what is the path, like how far is it that the plane is traveling to land at the airport. So again, don't forget to ask yourself, where are the sides in relation to the angle? If this is x, x is equal to the plane distance to the airport. Certainly this is new, so to airport. Okay, and then when you ask yourself where are the sides in relation to the angle, remember that this is hypotenuse, where the x is, and 3,500 degrees is opposite, which trig function is opposite in hypotenuse. That's sine. So sine of 2 degrees is equal to 3,500 over x. Don't forget to multiply both sides by x to start. Get it out of the denominator. Now you have x times the sine of 2 degrees equals 3,500. Then divide by sine of 2 degrees. And then you get x. Remember, you need a calculator ready. Answer is 3,500 divided by sine of 2 degrees. Now you're ready to type it in. So plane is approximately 100,288 feet. We are in feet, right? From JFK. And not that I asked you this, but if you really had to convert it to miles, what would you do to convert it to miles? You would divide in miles, divide by 5280 so that you could see about how many miles that is. Remember that that's how many feet are in a mile. So it's about 19 miles, approximately 19 miles. Okay. So if it's in feet, and I didn't specify, so usually you're just going to answer according to that. All right, on the next page, an airplane pilot sights a life raft 26-degree angle of depression. The airplane's altitude is 3 kilometers. What's the airplane's surface distance? Surface distance is a little bit different. So there's your airplane right here, flying at an altitude of 3 kilometers. And there's the life raft over here in the water. Okay. And the 26-degree angle of depression. Don't forget that the airplane, the pilot is looking straight out at the sky and then along the line of sight down to the raft. And this is your 26-degree angle of depression. Don't forget that this is a horizontal and this is a line of sight. And you can take the 26 degrees, and if it's easier, you can also put it here. Because alternate interior angles of parallel lines are congruent, we're going to assume, obviously, that the plane is flying at a height perpendicular to the ocean. Okay? And where are the sides? And we want to know what's the surface distance. So if we want to know the surface distance, be careful. Surface distance, that would be here. That would be along the water. Surface distance is here. So surface distance would be along the water or along the ground. So again, you're going to have to ask yourself where are the sides in relation to the angle, and 3 kilometers is opposite. Surface distance is adjacent. So which trig function uses opposite and adjacent? Tangent of 26 degrees equals 3 over d. And then you follow the same thing, multiply by d on both sides. And then isolate, don't forget to divide by tangent of 26. So I'm skipping that step. So you get d equals 3 divided by tangent of 26 degrees. So the surface distance is approximately, I have to type it in, 3 divided by tangent 26. Don't forget to check and make sure that your calculator is in degree mode. So the surface distance is approximately 6.2 kilometers. I'm just putting it in the nearest tenths. If I don't say, then you have to check your directions. Sometimes I'll tell you what specific place to round to, and if I don't, then I guess I need to take some different forms of answers from you. And then I think this is the last one. Yeah, this is the last one. You should probably like pause the video, try it on your own, see what you can do, because the problems are going to get a little more harder, a little harder and a little more challenging. So to approach runway 17, remember that 17 is not really part of the problem of Ponca City Municipal Airport in Oklahoma. Pilot begins a 3-degree descent starting from an altitude of 2714 feet. The altitude of the airport is 1,007 feet. How many miles from the runway is the airplane at the start of this approach? So got to be careful of giving you more information in this problem. And here is the difficulty with this one is that, you live in New Orleans, you live in a flat city that is at about sea level, if not a little bit below sea level. And so you're not used to things necessarily being already at an altitude. But here's really the situation that's going on. The pilot is flying his airplane, right? And he is flying at an altitude of 2714 feet, but the altitude of the airport is already 1,000. So here's the airport right here. And the altitude of the airport is at 1,007 feet, so that you are paying attention to the fact that you're going to have to subtract something. So really what that means about the airport is that the airport is at an elevation of 1,007 feet above sea level. So the plane is flying at an altitude of 2,714 feet above sea level. The airport is at an altitude on land at an altitude of 1,007 feet above sea level. So you're going to have to subtract a little bit, okay? And get your triangle a little bit like this. Remember that the pilot begins a 3-degree descent. So you always have, don't ever forget, please don't ever forget, this is probably the biggest thing that students forget, is that they forget that they have to make it with a horizontal line. So 3 degrees, and you can put that in here because alternate interior angles are congruent if you wish, right? But 2714, remember, was that whole entire thing. So you're going to have to subtract 2714 minus 1007 so that you can figure out this side of the triangle over here. It's going to be 1707 feet, all right? And we want to know how many miles from the runway is the airplane at the start of this approach. So here's the runway over here at the airport. And if we're looking for this distance, we want to know that I'm going to put an X right here. And X is equal to miles between the plane and the runway. Okay. All right, again, where are the sides in relation to the angle? 1707 is opposite, and X is hypotenuse. Which trig function uses opposite and hypotenuse? That's sine of 3 degrees is equal to 1707 divided by X. Get the X out of the denominator. And then you have X times the sine of 3 degrees equals 1707. Don't forget to divide by sine of 3 degrees. And then your calculator-ready answer looks like this. X equals 1707 divided by sine of 3 degrees. Okay? And then type that in, and from the plane to the runway is approximately 1707 divided by sine 3 is approximately 32,616 feet. I'm not going to do that in miles. I'm just not going to take the time to do that. Okay. And then you should pause the video at this point and then try to draw your own picture for example 6, and then start it again and see what you have going on in just a minute. So I know this is getting to be way too long for you to hang in there, so I'll try to hurry a little bit. So I drew the picture already with a shorter building and a taller building. Keep in mind that that 30 feet that is along the ground, the distance between the buildings, that's 30 feet everywhere, okay? So then we're going to say tangent, where the sides in relation to the angle is opposite over adjacent, so tangent of 19 degrees is equal to x over 30 feet, right? And then I really want the overall height of the taller building, which means I'm going to have to add in the 133 feet for the height of the shorter building. So we have 30 times tangent of 19 degrees is equal to x, and then don't forget to add 133 feet after you evaluate tangent. 30 times the tangent of 19 degrees, so 30 tangent of 19. This is x is approximately 10.33. So if I had 133, then the taller building is approximately 143.3 feet. Okay, I'm sorry that that took so long. There should be a worksheet posted under files in the fourth quarter for some word problems on sine and cosine and tangent, angle of elevation, angle of depression. You should give those a try, and then we'll talk about like an answer key to that later. I'm going to stop this and Hope this helps. I'm sorry it's so long.